In this video, we're going to talk about what's known as a double angle identity. Okay, so we have a few double angle identities. So the first one has to do with cosine. And so when we have a double angle, we're going to say cosine of 2 theta is going to equal cosine squared of theta minus sine squared of theta. Now, there is another way that we could write the double angle for cosine. So we could also say that it is 1 minus 2 sine squared of theta, or we can also say 2 cosine squared of theta minus 1. So 3 different ways to write the double angle. So notice that it's double angle because there's a number in front of my theta, right? So if there was a 3, it'd be a triple, 4, quadruple. Notice that there's a single theta on all of these. Okay, so cosine has 3 different ways that we can write it. Sine and tangent only have one way. So sine of 2 theta will just be 2 times sine of theta cosine of theta. And then tangent looks like this. So tangent of 2 theta is equal to 2 tan of theta divided by 1 minus tangent squared of theta. Okay, so how can we actually get these double angle identities and how can we memorize them? Well, we can, or derive them. So we're actually going to prove that these are your double angles. So, and what we're going to do is we're going to use the sum and difference of sine, cosine, and tangent. So prove the double angle identities. All right, so the first one we're going to do is we're going to prove the cosine of 2 theta. Okay, so how do we actually get the cosine of 2 theta? Well, that would be the same thing as saying the cosine of theta plus theta, right? Because theta plus theta gives me 2 theta. If I have my thetas, consider this kind of like my A and my B value, okay? We can use our sum and difference of a cosine. So to be cosine of my first angle, A, times cosine of my second angle, so we'll call that A as well, or B, and then opposite sign. So if we see plus, now we see subtraction. And then it will be sine of theta, and then another sine of theta. Cosine of theta times cosine of theta, that's where I get cosine squared. And then sine times sine gives me sine squared of theta. So that's how we prove our first cosine. If I want to prove the other ones, right, so we had 2 other ones, what I'm going to use is I'm going to use my Pythagorean identity, right? So my Pythagorean identity, which told me that sine squared of theta plus cosine squared of theta was equal to 1. So notice that these both have either a cosine or a sine that are both squared. So I'm going to go ahead and I'm going to replace one of these. So if I say sine squared of theta is equal to 1 minus cosine squared of theta, I'm going to replace that guy in, oops, not right there. I'm going to replace him right here. So this would be the same thing as saying, right, cosine squared of theta minus, and then parentheses, 1 minus cosine squared of theta. Notice what happens, cosine squared of theta minus 1 plus cosine squared of theta. How many of the cosine squareds do we have? We have 2. So again, this is how we can prove it one more time. What else could I do? Right? Well, with my Pythagorean identity, I could also have said that cosine squared of theta is really 1 minus sine squared of theta. So what happens if I replace this guy in for this instead? So I'll put it over here. it would be 1 minus sine squared of theta minus sine squared of theta. And again, I could put parentheses around that. It's not necessary because it gives us, there's nothing to distribute. How many sine squares do we have? I have 2. So minus 1 minus 2 sine squared of theta. All right, so that's just one way to prove. Let's prove the other two. So let's prove the double angle for sine. So sine of 2 theta. So again, that's the same thing as saying sine of theta plus theta. And again, this is like saying A and B. So sine, cosine, cosine, sine. Keep the sign. So how many sines and cosines do I have? And again, it doesn't matter if we say 2 times 4 and 4 times 2, they're still going to give us the same answer. So we have 2 of them. So we say 2 times sine of theta, cosine of theta. And then let's prove tangent. So tangent of 2 theta. So again, that's the same thing as saying tangent of theta plus theta. So this means that I have tangent of theta plus the tangent of theta, right? Like my A and my B. And then 1 minus tangent of theta times tangent of theta. How many tangents of theta do I have on the top? I have 2 of them because they're being added. And the bottom, they're being multiplied. So that's where the squared comes from. So in reality, you don't actually need to ever memorize your double angles. You can always derive them. Okay, so what we're going to do is we're going to take this newfound information and we are going to find the values of 6 trig functions of theta, so notice regular theta, given this information. Cosine of 2 theta was equal to 3 over 4, and that theta is in quadrant 3. And if you want to pause the video, you want to try this first on your own, it's perfectly fine. Okay, so I need to find all 6 trig functions. So again, what I'm trying to find is sine of theta, cosine of theta, tangent of theta, and then its reciprocals, right? Cosecant, secant, and cotangent. So that's what I need to find. Okay, so how do I go about doing this? Well, I'm going to use one of my identities. So I know that for double angle of cosine, I have 3 different ways I can write it. I'm going to replace one of these equations with my fraction. Now, if I look at my top equation, I have 2 trig functions. So this one probably is not the best one to use. But I notice that the bottom 2 only have 1 trig function. So I'm going to use either this one or this one. I'm going to go with this equation. Cosine, actually I'll put it, I'm going to change my color so we can see. I'm going to say the cosine of 2 theta is equal to 2 cosine squared of theta minus 1. So it's an equation. I have 2 unknown variables, cosine of double angle and the cosine of the regular angle. So I'm going to go ahead and I'm going to replace. So what am I going to replace? I'm going to replace my cosine of my double angle with 3/4. So that means I'm going to replace this guy right here. So I'm going to say 3/4 is equal to 2 cosine squared of theta minus 1. So now let's go ahead and add 1 to the other side. Instead of adding 1, I'm going to add it as 4 over 4, right? It's the same thing as 1. So I'm going to get 7 over 4 is equal to 2 cosine squared of theta. I'm then going to multiply both sides by 2, or 1/2 to get rid of the 2. So I get 7 over 8 is equal to cosine squared of theta. And then I'm going to take the square root. And so remember, when you take the square root of a fraction, this is then becoming the square root of 7 all over the square root of 8. Right, a little plus or minus, because I, again, got to figure out which quadrant I'm in. So cosine of theta. Simplify 8. So this becomes the square root of 7 over 2 root 2. And then we are going to rationalize our denominator. So we're going to multiply top and bottom by root 2 over 2. So this is going to give me plus or minus the root 14 all over 2 root 4, which then again plus or minus root 14 all over 2 times 2. And again, I'm showing all of the little itty bitty steps. So we are going to get plus or minus, right, root 14 all over 4. So we have to remember that we are in the third quadrant. So in the third quadrant, we are negative. So this becomes a negative 14 all over 4. When I want to find my secant, right, I'm just going to flip my fraction and then rationalize my denominator. So I get 4 root 14 all over 14, and 4 and 14 can simplify. So for secant, I'll say that this is negative 2 root 14 all over 7. So how do we find the other terms? Okay, well, I could use the double angle again, right? Or we can now use our x squared plus y squared is equal to r squared. Okay, so if we remember that cosine is really x over r, right? I can plug in the root 14, negative 14, squared that. I don't know my y value, and my r happens to be 4. So I get 14 plus or minus, plus y squared is equal to 16. Subtract 14 of both sides. I get 2. Y is equal to plus or minus the radical of 2. But again, I'm in quadrant 3. So if you're thinking about it, quadrant 3 is down here. Your x and your y are negative. So this will actually be a negative root 2. So for sine, your sine will be a negative root 2 over 4. Okay, I'm going to rationalize here. So again, 4 over root 2, multiply root 2 by root 2, 4 root 2 over 2, and these simplify together, leaving you with negative 2 root 2. All right, last but not least, again, I'll color coordinate it for tangent and cotangent. So tangent is going to be your y all over your x. And again, we have to remember we're in quadrant 3, so tangent and cotangent are both negative, or sorry, both positive. So that's a great thing. I can simplify my fraction. So this will end up giving me a 1 over root 7, which then I can rationalize, and it's just root 7 over 7. Right? For cotangent, I'm just going to flip this guy right here. So this will just be a positive root 7. Okay, and if you're wondering how I got 1 over 7, think about root 2 over root 14. It's the same thing as saying 2 over 14. I'm simplifying it 1 over 7 and then putting it into its own radicals. Radical of 1 just stays as radical of 1, or just stays as 1. Okay, let's try a different type of problem. So this time, what we're going to do is we are going to find 2 theta. Let me write that better. Find 2 theta for sine, cosine, and tangent. Now we can also have a double angle for secant, cosecant, and cotangent. All you have to do is flip these 3 fractions over. but we're just going to focus on these three for right now. Tangent of theta is 5/3. And what do we know? We know that the sine of theta is less than 0. So based on this information, right, first thing I'm going to do is I'm going to figure out what quadrant theta is in, if that's going to help me with anything else, right? So if tangent's positive, so tangent is positive in the first and third quadrant, where is sine negative? In the third and fourth quadrant. I now know that theta, right, is in quadrant 3. Okay. In order to find my double angles, right, let's start off with sine's double angle. So sine's double angle, I'm going to need sine of theta and cosine of theta. Unfortunately, I don't know any of that information yet, so I'm going to leave that blank. For cosine of 2 theta, I'm going to start with cosine of 2 theta. I'm going to, again, go cosine squared of theta minus sine squared of theta. Again, I don't know any of that yet, so I'm going to leave that blank. Now tangent squared of theta, right, is 2 tangent of theta divided by 1 minus tangent squared of theta. I do know this information. So let's go ahead and find tangent first. So tangent first is going to be 2 times 5/3 all over 1 minus 5/3 squared. So what does this give us? This gives us 10/3 and then 1 minus 25/9. So this will become, bring it up here, 10/3 divided by 9/9 minus 25/9. And then we're going to continue, parentheses. We're going to say 10/3 divided by negative 16/9. Simplify it. So 10/3 times 9/negative 16. 3 and 9, leaving you with a 3. 16 and 10, so 2 goes into both, so 5 and 8. So 5 times 3, that gives me 15, all over a negative 8. So my double angle for tangent, right, is negative 15/8. So how do we figure out the rest? Well, I'm going to use my knowledge of what tangent is. Tangent is going to be y/r. So I'm going to say 5 squared, oh sorry, not 5/r, my bad, 5/x, misspoke. So 5 squared plus 3 squared is equal to r squared. So 25 plus 9, that gives me 34. So 34 is equal to r squared. R is always positive, no matter what. Now, let's see what happens if I don't rationalize right away. So for sine, I could just say 5/√34. For cosine, I'm going to say 3/√34. Now, I'm in the third quadrant, so that means that both of these are actually negative. But here's the great thing. The two negatives are going to cancel each other out eventually. And I don't also care about the 34 because the radicals are also going to cancel each other out. So really you have 2 times 5 times 3 all over 34. 2 goes into 34 17 times. So in reality, 5 times 3 is 15 all over 17. So notice that even though the single angle of sine is in the third quadrant, notice that the double angle of sine ends up being positive. So what quadrant could I potentially be? Notice the double angle is positive for sine, it's negative for tangent, so I'm definitely not in quadrant 3 anymore. And then I'm going to do the same thing for cosine. So cosine, or double angle of cosine, so again, negative 3 over root 34, and then minus, and then this would be negative 5 over root 34. Again, these are squared. I forgot them earlier. So again, I don't care about rationalizing because when I square the radical, it will go away, and the negatives also will go away. So it'll be 9 over 34, and then minus 25 over 34. Subtract those together. I'm going to get negative 16 all over 34. And for this one, we can simplify this. 2 goes into both. So this is actually negative 8 all over 17. Now, I want you guys to remember that tangent is made up of x, y over x. Notice that for the double angle of sine, your numerator has a y over r. Notice that for double angle of cosine, x over r. And if you take these x's and you take the y's, if you divide them, right, 15 over negative 8, notice that we get the same thing. So even with double angles, we have other identities that we can continue to work with. So we could have actually saved our little bit of time for tangent, and we could have said this. Tangent of 2 theta is the same thing as saying, or sine of 2 theta all over the double angle of cosine of 2 theta. So we could have said that 15 over 17 divided by negative 8 over 17, flip it, and notice that the 17s cancel out and you're left with 15 over negative 8, just like what we got over here. Right? So again, I just want to show you that there is more than one way sometimes to get your answer. Okay, the last type of problem I want to show you is something that looks like this. We are going to express the function as a trig function of x. Basically what this means, put a little star, it means to get rid of any coefficients with the x. Okay, so here's our problem. We have cosine of 3x. Okay, so what we need to do is we need to get rid of this 3. So let's start with, well, what identity could I use to kind of break this apart? Well, I could say that cosine of 3x is the same thing as saying cosine of 2x plus x. I'm going to use my sum of a cosine identity. When I do this, right, again, 2x is like my a and x is like my b. So now this becomes the cosine of 2x times the cosine of x, opposite sign, sine of 2x times the sine of x. So the question is, have we gotten rid of all of our coefficients? And the answer is no. We still have this guy to get rid of, and we still have this guy to get rid of. Okay? So let's continue. I'm going to replace the double angle of cosine with cosine squared of x minus sine squared of x. And I'm not replacing the other cosine x, that stays by itself. And then there's only one thing I can replace the double angle of sine with, and that is with 2 sine of x cosine of x, and then sine of x. So again, this guy goes right here, that guy went right here. Notice single x, single x, single x, single x, single x, single x, right? All the single x's all the single x's. They're all there. Okay, so we can simplify this. Let's get rid of our parentheses. So I'm going to multiply the cosine in. So cosine of x times cosine squared of x. That's going to leave me with cosine cubed of x. And then cosine x times sine squared. So that'll just be sine squared x cosine of x. Minus, and then the sine is going to be multiplied inside. So minus 2 sine squared x cosine of x. Now, can I simplify this even more? Absolutely. Totally can. I can combine these two guys together. So I have sine squared cosine of x 2 times. So this becomes cosine cubed of x minus 3 sine squared of x cosine of x. And this is the same thing as cosine of 3x. So it's almost like a proof. It's almost like verifying identities. Okay, but again, I don't care if I have a coefficient. I don't care about this coefficient, this one right here, right? Because it's on the outside of my trig. What I care about is if it's right next to my x. I got to get rid of it. And again, I don't care if there's an exponent. And so that's what it means to express the function as a trig function of x. It means to get rid of any coefficients.